Hello everyone. Today I will be giving a detailed session on microservices architecture. Microservices architecture. What it is, why companies are using it, how it works internally, and how we build microservices using technologies like Spring Boot. And also I will walk you through real world examples, advantages, disadvantages, communication patterns, and also API gateways, services discovery, and best practices. Now we will go to our first topic. What is microservices? Like what are microservices? Now we will see in detail. Microservices is a architectural style. It is a architectural style where large applications is broken into small style. Uh, Large applications are broken into small applications. So this is the microservices and independent services also. It breaks into independent services, and each service runs on its own, has its own database and communicates with each other through APIs. Every microservice, every microservice has its own databases, database, and also communicate each microservices via APIs. Like for example, for example, uh, sh- let's take shopping website, like shopping website, and it has different services. It has different services like first service is product service, and second one is cart service, like where like whatever the products you like, you need to add into cart before placing the order. So it is a some separate service. And third service is payment service, like after adding any product into cart, you need to pay for that product. So it payment service. Those are all independent services. And also notification service. After placing the order, you will receive the notification about the service detail, like product placed details. Notification service. And also last, order service. So these are all microservices which are independently work of shopping website. Now we will see why microservices are needed. Why microservices are needed. Before microservices, applications were built as monolithic. Like monolithic is one of the microservice architecture before microservices, and a monolith means the entire application is one big unit. Entire application is one big unit. The entire application is one big unit. It is not like microservices. One code base, one deployment. When user base increases, monolith has problems. Uh, problems, problems in monolithic architecture. One is slow development. The second problem is slow deployment. Like small change is called to deploy whole application. When you make any small change, you need to deploy entire application in the cloud. So slow deployment, and also scaling issues. We can't scale only one feature. Scaling issues. And the fourth problem is tight coupling. One error can crash the entire system. Tight tight coupling. And are to adopt new technologies. For example, if a monolithic shopping app gets heavy traffic only on search, we must scale the entire application unnecessarily. So this is about why, what is the why microservices are needed. So these are the problems occurred while you use monolithic. So to avoid these problems, we need microservices as a architecture. Now we will see what are the different characteristics of microservice. Characteristics of microservices. One characteristic is independently deployable. One is independently deployable. Independently deployable. The other one is decentralized data management. Decentralized data management. The other one is lightweight communication. Fourth one is scalable at component level. Scalable at component level. For example, order service does not need to know how payment service stores data. They only communicate via API calls. Now, the other characteristics are polyglot approach. Different services can use different tech. So those are called services which use different technologies are known as poly polyglot approach, where different services use different tech, depends on their requirement. And the other one is resilient and fault tolerant. Like for one service, failure does not break entire system. So this is one of the important characteristic of microservices. resilience and fault tolerance, fault tolerant. The seventh one is automated DevOps pipelines. Automated DevOps pipelines. So these are the characteristics of microservices. Now we will see the real world examples where microservices are used. Now we will see the real world examples where microservices are used. Let's take our first example as Netflix. It serves over 200 plus million users worldwide. So our first example is Netflix. Our first example is Netflix. It serves around 200 plus million users. It serves 200 plus million users. And now we will see uh, if Netflix was monolithic, like if Netflix uses monolithic, if Netflix uses monolithic, then after we will see if Netflix uses microservices. Now in that case, one bug is recommended engine is equal to entire app down. One bug in recommendation engine is equal to entire app down. Global code deployment would be slow, hard to scale video streaming for peak hours. If Netflix uses monolithic approach, some of the problems will occur. Let's see what are those problems. One bug occurs, it is equal to entire app down. So we can't use app. The second problem is global code deployment would be slow. The third problem is how to scale video streaming for peak hours. Video streaming at peak hours. So these are the problems occur when these are the three problems occur when Netflix uses monolithic approach. Now if Netflix uses microservice approach, microservice approach. It so Netflix created microservices like it creates services like user service, billing service, movie service, and also notification service. Like when new movie is released, you will get notification. So each can scale independently. These services scale independently. So if streaming demand increases, Netflix only scales the video streaming service, not the entire system. Now we will see how microservices communicate. Now we will see how microservices communicate. First one is synchronous communication. Microsoft communication. It uses REST APIs and direct service to service calls. It uses REST APIs, direct service to service calls. But the problem is, if one service is slow, chain effect happens. Problem is, if one service is slow, chain will collapse. Now we will see other type of communication, that is asynchronous communication. Message queues. One is message queues, like Kafka. Other one is Rabbit MQ and AWS SQS. Best for high performance and loose coupling. Those are for best for high performance and loose coupling. For example, when a user places an order, order service sends event, and then payment service processes send event, notification service sends email. For example, order service sends event, payment service payment service processes, and after that sends events and also notification service sends email. So these are the communications of microservices. Now we will see advantages and disadvantages. Advantage, advantages and disadvantages. Advantages of microservices. First we will see advantages of microservices. Our first advantage is fastest deployments. Second advantage is technology flexibility. Our third advantage is scalability. Our fourth advantage is fault isolation. Our fifth advantage is better deployment, better development speed. Our sixth advantage is autonomous teams. So these are the six advantages of microservices. Now we will see advantages of disadvantages of microservices. Disadvantages of microservices. One is complex architecture. Second disadvantage is requires DevOps culture. Third disadvantage is high monitoring requirements. High monitoring requirements. Fourth disadvantage is network latency and failures. And our fifth disadvantage is data consistency challenges. Now let's conclude our demo. Mm, Conclusion. Microservices break a large system into independent services. Breaks large system into independent services, and it helps with scalability, faster deployment, and reliability. Helps with scalability, faster deployment, and reliability. And uses uses tools like API gateways, Heroku, and config server, and last Kafka. The, so these are the conclusions of our microservices system. And there are other two things also there. They are recommended for large, complex applications. And our last conclusion is requires strong DevOps practices. And thank you.